So in this video we are going to talk about Gauss elimination method, and the steps which are involved in Gauss elimination method is forward elimination, and the second step is called backward substitution or back substitution. So suppose this is my matrix system, which is A and X is equal to B, and I want to find out the solution of this AX is equal to B. The matrix A has this form, having element A11, A12, A13 in the first row, A21, A22, A23 in the second row, and A31, A32, A33 in the third row. And we have the unknowns x1, x2, x3, and the known constant b1, b2, b3. So here we are talking about 3 cross 3 matrix because that is the simplest matrix, although we can talk about 2 cross 2 matrix, but that will not give me much idea, because two equations can be solved easily without much effort. So we are going with 3 cross 3 matrix system. We can extend it to higher order matrix system, but here let's talk about 3 cross 3 matrix system only. So we will represent the first row with R1, the second row with R2, and third row with R3. So first thing is, let us talk about pivot. So pivot we will generally call the first non-zero element in the row. So we will consider pivot as the first non-zero element in the row, and mostly we will try to select it on diagonal. And in forward elimination, what we will do, we will make all the element below this pivot as 0. So that is called forward elimination. Essentially here what we are doing, we are trying to convert this matrix into a upper triangular matrix, or we can also convert this matrix into lower triangular matrix, but here we will go with upper triangular matrix. So this matrix system A will convert it into upper triangular matrix by making elements below the pivot as 0, and often we will select this pivot at the diagonal. So how will we do it? We will do it with row operations. So let us understand these row operations involved in this forward elimination. So I have this A11, A12, A13, A21, A22, A23, A31, A32, A33, and this B1, B2, B3. So we are here talking about forward elimination. So the idea is that select a pivot, make all the elements below this pivot as 0. So in the first step we have this pivot, that is A11. So what we will do, the first step is that select this pivot. So we have selected the first pivot, and so in the first step pivot is A11, which is obviously non-zero. If it is 0, then we will try to swap the rows. If A11 is equal to 0, then we will swap the row. This is called partial pivoting. Or swap the column, and this is called complete pivoting. We'll understand these things with an example. in the next video, where we will see partial pivoting and complete pivoting. Here we are considering that pivot a11 is not equal to 0. So essentially what we want to make a21 is equal to a31 is equal to 0. That is our target. So what row operations should we do? So row operation is make R2 is equal to R2 minus R1, that is row 11 times A21 upon A11, and R3 is equal to R3 minus R1 times A31 upon A11. So this is in what row operations we will follow? First we will do A. In this first step, A is make R1 is equal to R1 or I would say that R2 is equal to R1, that is row 1 upon A11 minus A21, and R3 is equal to, so this is my row operation. So what will happen? See, look, if I multiplied row 1 with A21 upon A11, then this element will become what? A11 upon A11 into A21. So essentially this becomes A21. So what we are doing? We are subtracting A21 minus A21. So the first element in row 2 has become 0. Similarly, if R1 is multiplied with A31 upon A11, then the first element in this expression is nothing but A31, and if I subtract this from A31, then this element also becomes 0. So essentially after step 1, what we have achieved, that row 1 is intact, that is A11, A12, A13, but these element in row 2 and row 3 has become 0, and we will have the change in A22, that will become A22 prime with that row operation, and A23 prime with the second row operation, and A32 prime, A33 prime. Also we will have changes in the B1, B2 prime and B3 prime, because since we are doing row operation, so row operation will also affect the coefficient B2 and B3. Now here also it might so happen that this diagonal element which we are going to select for the next step, that is second step, select next pivot in the next row. So here the pivot becomes A22 prime. Okay, so the next, select next pivot in the next row, but remember, if this pivot is 0, then we will basically if this pivot becomes 0, then we will swap the rows or swap the column. If we swap the rows, then it becomes partial pivoting. If we swap the columns, it becomes complete pivoting. That we will understand with an example, as I have told you already. So now we want to make A32 prime is equal to A33 or is equal to 0, because this is pivot and the element below the pivot is only A32 prime, and we want to make it 0. So essentially what we will do, we will do this R3 is equal to R3 minus R2 A32 prime upon A3 A22 prime. So this makes my matrix, this is my step 2, so this makes my matrix as A11, A12, A13, 0, A22 prime, A23 prime, 0, 0, A33 prime, X1, X2, X3, B1, B2 prime, B3 double prime. Remember, since B3 will change with this row operation. So what we will do, basically, if there are more number of rows, then we will follow this procedure, that we will select this pivot at the diagonal and we make all the elements below this pivot as 0 with this row, this kind of row operation. Then we will select the next pivot in the next row and do the same. We will make the elements below this pivot as 0, and in the next step we'll select pivot in the next row and do the same. So with this kind of row operations, we'll try to convert. We have converted this matrix A in an upper triangular matrix. So after forward elimination, what we have seen, we have a matrix A11, A12, A13, 0, A22 prime, A23 prime, 0, 0, A33 double prime, X1, X2, X3, B1, B2 prime, B3 double prime. Maybe in the previous slide I have forgot to put this double prime on A33, but remember that after each row operation or after a row operation in that particular row, the elements will change as well as the coefficient in the B matrix will also change. So now the second part is back substitution. So here what we are doing, so essentially this A3 is nothing but what, B3 double prime upon A33 double prime. X2 is nothing but B2 prime minus A23 prime times X3 upon A22 prime, and X1 is nothing but B1 minus A12 X2 minus A13 X3 upon A11. So what we are doing, we are back substituting the values of X. So first we will calculate the X n, here n is 3, so we'll calculate X3, and then with the help of X3 we'll back substitute this X3 into X2 and then calculate X2, and similarly back substitute this value X2 into X1 into the expression to calculate this X1 value. So this is what is called Gauss elimination. So here what we are doing, with the help of forward elimination, that is nothing but row operations, we are converting matrix A into an upper triangular matrix and then doing the back substitution to calculate vector x. So this is Gauss elimination. In the next video we'll take this example and we'll take one more example that will show the partial pivoting or the complete pivoting. Thank you.